Welcome, everybody, to day 2 of the Spring Celebration of Mind Week. I'm your host, Bob Hearn, and it's my great pleasure today to introduce James Tanton. James is the author of more than 10 books. He's an ambassador for the Mathematical Association of America. He's the founder of the Global Math Project, which has reached more than 6 million students and educators. And I have to say, personally, I'm very intrigued by his abstract and looking to see what happens when you repeatedly split piles of 9 objects. And I'm very curious about the amazing mathematics that results. So without further ado, James, feel free to take over.
G'day, well, what a pleasure to be here. And thank you, friends, for coming along. I recognize many names as well. I'm very honored you're here, every one of you. That's wonderful. What a joy. Okay, so we're going to do pile splitting, then we should do pile splitting. Which means you are now currently seeing 9 objects. I've got 9 pebbles. It can be 9 of anything, but not zucchini. Squash, pennies, whatever you like, buttons. Here they are. So let's do, I'll do the classic puzzles. And I'm going to rip off a very famous puzzle that's been around at least for decades. Here is 9. If I counted correctly, I think it's 9. Yes, that's 9 pebbles. Just split them any way you like. Maybe I'll do, say, 4 and 5. And just for kicks, here's the classic version of the puzzle. Just write 4 times 5 on the side of the page. 4 and 5, the product is 20. Why am I doing that? Because I'm just doing it. That's why. But then let's keep splitting. I might split that pile of 4 into, say, 2 and 2. In which case, I'm going to write on the side of my page 2 times 2, which is 4. I might split the 5 into, say, 3 and 2, and then in which case I'm going to write 2 times 3 on the side of my page being 6. Keep splitting. 2 into 1 and 1, so 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. They're pretty boring, but let me write those products nonetheless on the page. 1 times 1 is 1 3 times. Oh, it's got that part of 3. Let's keep splitting. Why not? 2 and 1. So 1 times 2 is 2, and the final split, the last split I can do is 1 and 1. 1 times 1 is 1. So I split those 9 pebbles as much as I can. Now I've got 9 single piles of 1. But I've also created these crazy products on the side. Now what I'm going to do to those products, I'm going to add them together. 20 and 10, that gives me 30. 1, 2, 3, 4, 5, 6. That gives you the magic number of 36. So as I played that splitting game, making these choices along the way, I got the magic sum of 36 in the end. All right, but here's the magic. Here's the classic puzzle, which I'm doing right now. I'll do it again. But let me make different choices along the way. I start with a split of 4 times 5. Now I'll do something like, say, 2 and 7. There's 2 times 7. I'll write that on the page this time, and that's 14. Completely different choices. I'm also do this 2 into 1 and 1 right now. 1 times 1 is 1. That's 7. Maybe I'll do 2 and 5 and write 2 times 5 on the page, which is 10. Oh, I might as well do that quick too. 1 and 1. 1 times 1 is 1. I've got that 5. Now I'll do 4 and 1. Why not? Be crazy. 1 times 4 is 4. That was crazy indeed. That 4, let's make it 2 and 2. Why not? 2 times 2 is 2. Oh, no, it's not. It's 4. If I can only do arithmetic, that would be helpful. Oh, 2, 1 and 1. 2, 1 and 1. Okay, 1 and a 1, 1. 1 times 1 is 1. Great. Let's add up those products this time. 15, 25, and another 5 makes 30. 34, it's 36. Whoa, whoa, you get the same number, 36. In fact, that is the classic puzzle. No matter how you choose to split these pebbles apart, you'll always get the magic sum of 36 in the end. Okay, all right. You may have seen that before. It's been around for decades. But here's what I want to do. I want to keep playing. I want to get wild and crazy. I'm going to do it again, but let me do a variation. Instead of doing products, let's do the following. In fact, I won't even bother drawing the pebbles now. I'll do it actually as a tree. Here's 9 pebbles. Suppose I split into 5 and 4. Okay, this time I'm going to do some freaky fractions. I'm going to write the fraction 1/5 and 1/4. Instead of multiplying this time, I'm going to add 1/5 plus 1/4. Oh, golly gee. Okay, this is terrible arithmetic. That's 4 20ths and 5 20ths. That makes 9 20ths. Great, 9 20ths. Now let's split again. So maybe split the 5 into, say, 2 and 3. And I'm going to write 1/2 plus 1/3, and I believe that's 5/6. Maybe I'll split the 4 into, say, 2 and 2. 1/2 plus 1/2 equals 1. Maybe I'll split the 2 into 1 and 1. 1/1 plus 1/1 equals 2. Maybe I'll split the 3 into 2 and 1. 1/2 plus 1/1 equals 3/2. Maybe I'll split that 2 into 1 and 1. 1 plus 1 equals 2. Split that 2 into 1 and 1. 1 plus 1 equals 2. Split that 2 into 1 and 1. 1 plus 1 equals 2. All right, I'm off the page now, but there we go. Oh, but this time, since I actually added the fractions before, this time I won't add them in the end. I'm going to multiply all these fractions together. This is crazy. All right, let's go do it. 9/20 times 5/6 times 1, I won't bother writing that, times 2 times 3/2 times 2 times 2 times 2. All right, what is that product? A 2 cancels there. A 2 times a 3 and a 6 cancels there. Let's see, what else have we got going on? So I'm just trying to see my own screen here. What cancels? Oh, 5 times 2 times 2, that's 20, cancels that 20, and I'm left with just a 9 on the top. The product of those fractions is the number of pebbles I started with. Oh, surely that's coincidence. That's just pure coincidence. So let's do it again. Let's double check that. Let's do some freaky fractions. Let's make different choices along the way. Let's take the number 9. Let's say split into 2 and 7 this time and do 1/2 plus 1/7. They're going to be 14ths. That, I believe, is 9/14ths. Is that right? 7 over 7 14ths and 2 14ths. It's 9/14ths. Great. The 2, 1 and 1. 1 plus 1/1 plus 1/1 makes 2. 7. Let's do 3 and 4. 1/3 plus 1/4. That's going to be 7/12ths. 7/12ths. I think I'm doing it correctly. I cannot actually do arithmetic. This is very hard, so hopefully I'm doing it correctly. Let me know in chat if I'm making a mistake. The 3, the 1 and 2, say 1/1 plus 1/2 is 3 halves. 2, 1 and 1. 1/1 plus 1/1 makes 2. 4. Let's do 1 and 4. Why not? 1 plus 1/4. 1/1 plus 1/4 is 5/4. 4, 2 and 2. 1/2 plus 1/2 equals 1. 1/1, 1/1. 1 plus 1 equals 2. 1 plus 1 equals 2. And this time, let's multiply those fractions. I'll do it in a different color so we can see it. 9/14ths times 2 times 7/12ths times 3 halves times 2 times 5/4ths times 1, I won't bother writing, times 2 times 2. What is that product? Well, 2 times 7 and the 14 cancel. Let's see. A 4 and a 2 and a 2 cancel. What I got this 5. Did I get that 5/4 there? Okay, let's go, keep going. Oh, we'd have that 5. I must have made a mistake somewhere. Did I make a mistake somewhere? Split 4 into 1 plus 4. That's my mistake. Oh, silly James, 1 and 3. Thank you. 1 and 3 makes 4/3. Oh, golly gee. Then I should do this a 1 and a 2 makes, oh, I do. But you know what? To save time, guess what? If you did it correctly and you multiplied all the fractions together, can you type into the chat what the answer is going to be? Can you guess what the answer is going to be? Because James can't do arithmetic. According to the answer, what's it going to be? You bet. The product of those fractions is 9. Okay, all right. Thank you for saving me because my brain cannot handle basic arithmetic. But let's not just do freaky fractions. Let's keep going. Let's just make the mystery even deeper with splitting 9 things into piles. This time, let me go completely weird. 9. Let's split it again, say 7 and 2. But this time, I'm going to be crazy. I'm going to write 7 as 7 ones, 1, 1, 1, 1, 1, 1, 1, that number, that 7-digit number. And I'm going to write 2 as a 2-digit number of nothing but ones. And then I'm going to multiply those together. I'll do multiplication this time. This will be this number, 7 ones times basically 10. It's going to be an 8-digit number. I bet you get 1, 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6, 6, 1. I bet you get that. Am I right? Did I do that correctly? 1, 2, 3, 4, 5, 6, 7, 8-digit number. I bet that's what it is. Great. Okay, there's 2. I'll split into a 1 and a 1. And I'll write a 1-digit number composed of ones times a 1-digit number composed of ones. That one I can do. My little brain can handle that. Well, let's bring this and say 3 and 4. Let's split it to 3 and 4. I'm going to write 1, 1, 1 times 1, 1, 1, 1. Okay, my brain is not very good. Let's bring up technology. Here goes. What is, whoops, clear. 1, 1, 1 times 1, 1, 1, 1 equals 1, 2, 3, 3, 2, 1. But I keep splitting. I'll split that 4 and say 2 and 2. 1, 1 times 1, 1 is 121. I'll split that 3 to say 1 and 2. 1 times 1, 1 is 11. That 2 into 1 and 1, that 2 into 1 and 1, that 2 into 1 and 1. 1 times 1 equals 1. 1 times 1 equals 1. 1 times 1 equals 1. Since I did multiplication that time, I'll now add everything together. So what is all that added together? 1, 2, 2, 2, 2, 2, 2, 1. 8 digits, yes, plus a 1, plus a 1, 2, 3, 3, 2, 1, plus a 1, 2, 1, plus a 1, 1, plus a 1 and a 1 and 1, 3 is this crazy number. 1, 2, 3, 4, 5, 6, 7, 8. Whoa, whoa. That's the 8-digit number of all the numbers up to 8, which happens to be 1 less than 9. Wow, what's going on? But if I do it again, but I will do it. In fact, you could do it again. Have your pencil and paper with you? Write down 9 on a piece of paper, split it into 2 numbers of different choice, and keep doing these crazy ones. Add up all the products. Do you get 1, 2, 3, 4, 5, 6, 7, 8 in the end? Try it out. But I'll stop talking. I'll do it too. I'll make different choices along the way and see if we get the same answer. I'll do a clean piece of paper. Since I don't trust my brain, I'm going to do this very carefully with a calculator. All right, I'm going to add up all my answers. That was 8 digits. Plus a 1, 2, 2, 2, 2, 2, 1, plus a 1, plus a 1, 2, 3, 2, 1, plus a 22, 23, 24, plus a 24. 1, 2, 3, 4, 5, 6, 7, 8 again. Whoa, this is crazy. This is absolutely insane. Whoa, I'm splitting 9 pebbles in half and into piles, and I'm getting crazy products. I'm getting crazy fractions, and I'm getting crazy ones. But there's more craziness before I explain what's going on. There's even more craziness. For example, look at this. I did 1, 2, 3, 4, 5, 6, 7, 8 splits. There are 8 splits in that example. In this example, there are 1, 2, 3, 4, 5, 6, 7, 8 splits. 8 splits. In this example, there are 1, 2, 3, 4, 5, 6, 7. Oh, I goofed on this one. That looks like I was going to do one more. 8 splits. 8 splits. In this example, 1, 2, 3, 4, 5, 6, 7, 8 splits. There's another invariant. The number of splits always seems to be 8. This is insane. Oh, actually, more is true. Look at this. Look at the pairs I'm getting. This one has 1, 1, 1, 1, 1, 1, 1, 1. It has 4 1, 1 pairs. This example has a 1, 1, 1, 1, a 1, 1, and a 1, 1. That's 4 1, 1 pairs. So I don't trust it. I don't think it's a real one. That's not. Oh, it doesn't have 4 1, 1 pairs. I'm wrong. But it has 4 odd pairs. It actually has 4 odd pairs. This one has 1, 2, 3, 4 odd pairs. This one has 1, 2, 3, 4 odd pairs. The number of odd pairs in all our examples is 4. There's a lot going on here. There's a lot going on here. So this is a half-hour talk. This is a mighty speedy talk. That leaves us 15 minutes right now for me to try to explain what's going on. Would you like me to explain what's going on? Something weird, something to do with binary numbers. So I just asked a yes/no question. Would you like me to explain what's going on? Would you like me to reveal what's in my head, James Tanton's little head, about what's happening here? Let me know. Yes is the answer. I agree. Clearly I want that answer. Here's what I was doing. I was so inspired by the classic versions puzzle about doing all these products. And there's a way to explain that about matching those strings between the pebbles and so forth, which is great. Until it dawned on me one day that, you know, there's actually something simple you can do. Pick your favorite sequence of numbers. I'll call my favorite sequence numbers A1, A2, A3, A4, and so on. Hang on, I can't see my own screen. Let me just move the chat bubble out of the way. I'm going to burst our bubbles. I'm going to burst our bubbles. So here's a sequence of numbers, A1, A2, A3, A4. And that sequence can be anything you like. For example, AN could be N. You can let the nth number be the number N, in which case I'm doing the sequence 1, 2, 3, 4, 5, 6, the counting numbers. Or I could, let's say, AN be N squared, in which case I'm doing the sequence of square numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So I'm doing the sequence 1, 4, 9, 16. Or maybe you could do AN as the nth Fibonacci number, if you like. Fibonacci, if I can spell Fibonacci correctly. Nth Fibonacci number. 1, 1, 2, 3, 5, 8. Choose any sequence you like, any sequence of numbers you like. And then I'm going to suggest something strange. Whenever you play this splitting game, you've got some pile of pebbles. So there's some pile of pebbles. And you split them into A pebbles and B pebbles. I suggest you write on the page this number, the 8th number in your sequence, plus the bth number in your sequence, and please subtract the number of pebbles you started with for that number of sequence. But that actually must be A plus B. You must have done A plus B pebbles split into A and B. So please subtract the A plus bth term in the sequence. Whoa, please write that on the side of your page. Which means that if you later go along and say split this B into say a C and a D, what you'll then next write on your page is, oh, I'll write the Cth term plus the Dth term, and I'll subtract where they came from, which I guess is A, B. And I'll keep doing that, keep writing things on this page. And here's the magic that happens. If I was to keep writing all these special things down on the page and then later add them together, look at that B. That bth term got used here as a positive number, and then later got used as a negative number. It cancels out. It cancels out. There's going to be a lot of cancellation going on as you play this pile splitting game. In fact, I actually wrote this out. I did prepare this talk. Here's a great big splitting picture of the 9 pebbles. Here's the rule I said. On the side of the page, choose your favorite sequence, but whenever you split into A and B, please write down on the page A, the 8th term of the sequence plus the bth term of the sequence minus the A plus bth term of the sequence. And I did that for this example of splitting 9 pebbles. So I first split into 5 and 4, and I literally wrote the 5th term plus the 4th term minus the 9th term. Then I split the 5 into 2 and 3. So then I wrote the 2nd term plus the 3rd term minus the 5th term. I did the 1 and 3 here, 4 into 1 and 3. So I wrote A1 plus A3 minus A4. And I kept doing that all the way along. And look what beautiful magic happens. As I said, there's a lot of cancellation. For example, this 4 got used as one of the numbers, the splittee numbers and the split all number. They got cancelled on. When I split the 4 this way, it got used on the left-hand side initially, but then later got used on the right-hand side. This 3, I bet where it is. This 3 must be this one here. It got used as a positive term on the left, but then later I split from it, so it got cancelled out later on. In fact, this 5 got used as a positive term and later got used as a negative term. This 2 got used as a positive term and later as a negative term. In fact, all these things are disappearing away. You can see all the stuff that's splitting away. The only thing that didn't disappear from this when I add up all these numbers is, well, that initial 9 got used as a subtraction at the very end, at the very beginning there, and never got used again in any other way. And all these ones kind of are half done. They're used on the left, but they're never used on the right. So all these A1s survive. So if I add up all these numbers, I know I must get 9 A1s. I know it's 9 pebbles being split up 9 piles of 1, and that minus A9 in the end. That is, it doesn't matter what choices are going on in between, it's all going to cancel out. All it's going to cancel out. All it's going to survive is 9 A1s as positive terms and that initial negative A9 at the beginning term. Whatever choice you make in the middle doesn't matter. It's invariant. Whoa, whoa. In fact, there's nothing special about the number 9 here. Start with n pebbles and just split away. You'll get n piles of 1, which is great. When you add up all these numbers, all the in-between stuff disappears. All you'll be left with is n A1s minus the initial AN, no matter what choices you make along the way. That is the key to having fun, because now all you have to do is play this game with any sequence you like. Choose your favorite sequence and see what happens. So let's do that. I've got 10 minutes to play with some famous sequences. So let's see if I play the splitting game with, say, the square numbers. Let's choose the nth term to be this nth square number. What's going to happen here? So every time I do a split, so here's some pebbles, and I split into, say, A and B, I'm going to write on the page the 8th term plus the bth term, A and B, and subtract where they came from, A plus B, which is, if I actually work this out, if my camera's going to be in focus, let's do that. All right, let's do that. That's going to be the 8th square number plus the bth square number, because that's my favorite sequence I'm playing with here, minus A plus B squared. All right, it seems irresistible to do the algebra, so we do the algebra. So I get A squared plus B squared, let's expand that out, minus an A squared, minus a B squared, minus a 2AB. Oh, stuff cancels, and I'm left with negative 2AB. Oh, that's kind of awkward. That's kind of awkward. No, let's do this. Let's do this. That negative 2 is annoying. So maybe I should start with the sequence negative 1/2 of the square numbers. So if I do that, I have negative 1/2 of this, negative 1/2 of that, negative 1/2 of that. All the stuff still cancels, and I'll get negative 1/2 of this. It'll be AB. Which means if I play with my sequence being negative the half of the square numbers, which seems really weird, I'll be writing on my page with each split just their product. That is their classic, that's the classic puzzle that everyone knows about from decades and decades. That this is just the product. Write down the product on the side of the page. What I'm really writing on the side of the page is this sum. And we know that this sum, no matter what you do, when you add up all the numbers in the end, it's going to be 9 copies of A1 minus A9, at least for 9 pebbles. In general, it's going to be, for n pebbles, it's going to be n copies of A1 minus AN. And for us, what is that? Let's work it out. If I'm doing the sequence negative half the square numbers, I'll get 9 times negative a half of 1 squared minus negative a half of 9 squared. Okay. Ooh, that's kind of weird. What is that? So I get 9 over 4 minus 9 squared over 2. Okay, am I doing this correctly? God, gee, am I doing this correctly? Oh, plus, James. Okay, great. What is that? I'm not squaring. It's negative half of 1 squared is negative a half. Thank you, James. And that's negative. Thank you. So this is 9 squared minus 9 over 2. 81 take away 2 is 72, divided by 2 is 36. There's the magic number we got at the beginning of today. Whoa. So that's the game I'm playing. Just choose your favorite sequence, and you know, if you keep writing that down on the page, everything's going to be invariant and fabulous. So let me do it again. I've got 7 more minutes to play. So I'm going to keep playing. You've got to love maths. This is awesome. I'm now going to choose the sequence AN, which is always 1. The first term is 1, the second term is 1, the third term is 1, the 13th term is 1, the 92nd term is 1. So whenever I split a pile into A and B, I'm going to write on the side of the page, A, the 8th term plus the bth term minus the A plus bth term. In this case, it's always 1. I'm going to write down 1 plus 1 minus 1. I'm always going to write down 1. Every time I split, I'm going to write down 1. Which means when I add up all these terms, what I'm really doing is counting how many times I'm going to split. So actually the sum I get in this game is the number of splits I do. But we know if you add up all these numbers, the number of splits you're going to get is given by the formula 9 copies of A1 minus A9, which is 9 copies of the first term is 1 minus the 9th term is 1, which is 8. You'll always get the number 8. As you play this game with 9 pebbles, the number split you're going to do is always 8. There it is. There are other ways to see that too. There's actually simpler ways to see that one, but there it is. Choose your favorite sequence and everything falls into place. And then I just had fun. I said, okay, I'm going to choose a really crazy sequence. I'm going to let AN be 1/2 if n is odd and 0 if n is even. Whoa. This is weird. This time I'm saying every time you do a split into A and B, please write down on the side of your page this number, AA plus AB minus A plus B. If you do that, think about it. If A and B are both even, then everything here is even. You'll get 0 if both A and B are even. If both of them are odd, you'll get 1/2 plus 1/2 minus, that'll be even because odd plus odd is even. So you'll get 1 if they're both odd. If 1 is even and 1 is odd, maybe A is odd and B is even, you'll get 1/2 plus a 0 minus, if one's odd and one's even, that's also odd. You'll get 1/2 plus a 0 minus 1/2. You'll get back to 0. You'll get 1 only if A and B are both odd. In which case, when you add up all these numbers, add them all up, you're really counting the number of odd pairs. And that number of odd pairs must be invariant. It's going to be 9 copies of A1 minus A9, which is 9 copies of A1. Oh, that's a half. 4.5 minus A9. Oh, that's an odd number. A half. Whoops, half. That's the number of 9 halves minus 1 half is 4. You will always see 4 odd pairs as you play the game. Whoa, whoa, this is so crazy and fun. But I've got 4 more minutes to keep on going. This is so jolly good. Let me do the crazy ones one. Remember the one I was doing about all the ones? Where is that coming from in the remaining 4 minutes? What did my brain do for that one? Well, I chose this sequence. I just had fun choosing this sequence, AN. It is crazy. I chose -1/81 of 10 to the n minus 1. Because why not? People naturally think of that. Okay, what was I? I wasn't naturally thinking that. No one thinks of that naturally. What was I doing? Well, I realized, for example, 10 to the n minus 1 is a great big power of 10 take away 1. So there's a whole bunch of 9s. It's going to be 9, 9, 9, 9, 9, 9. In fact, it's going to be n of them. N of them. Whoops, get my camera to focus. And I thought, oh, if I divide that by 9, then I'd actually get that divided by 9. I'd get my crazy ones. I'd get n ones. So I knew I wanted to do something like that. All right, so then look at that. I basically did that, but I did a 9. I actually realized I needed another 9 around the place, and also realized I needed a minus sign for things to be nice. Example, because when I take a pile of pebbles and split them to A and B, I'm going to write A, the 8th term, plus the Bth term, minus the A plus Bth term. Great. What is that going to be? Well, according to my crazy formula, that's -1/81, 10 to the A, minus 1, plus the Bth term, -1/81, 10 to the B, minus 1, minus, so it's now plus 81, 10 to the A plus B, minus 1. Okay, a lot of 81s around the place. So if I'll do 1/81th out of here, what survives? I get a 10 to the A plus B, minus a 1, minus a 10 to the A, minus a plus a 1, minus a 10 to the B, plus another 1. So I've got a -1, a +1, and a +1. I've got a +1 here. Oh, algebra now makes me realize this is really 1/81th, 10 to the A take away 1 times 10 to the B take away 1. This is really, put a 9 here and a 9 here, it's really A1s times B1s. So as I play the game, whenever I write this on the side of the page, I'm really writing a product of ones on the side of the page. I'm saying, please write on the side of the page this product. And we know that when you do this product, when you add this up, the sum has to be 9 times A1 minus 9 minus A9, no matter what. If you check that out, that turns out to be the number 1, 2, 3, 4, 5, 6, 7, 8. There is the crazy ones variation. But I did one more. I did crazy fractions. This time I decided to switch up the multiplication and the additions, just have fun. Instead of doing additions, I decided to focus on multiplications. So before I was writing A to the A term plus the B term minus the A plus B term, that's an additive version. I decided to do the multiplicative version of this. I'm going to write instead A to the 8th times A to the B divided by A to the A plus B. And before I was adding all those fractions, now I was adding all those, now I'm going to multiply all those. And so to show you how that works, do I have a piece of paper? Please, James, have a piece of paper somewhere that explains everything? Yes, here's my piece of paper. If you do a multiplicative version of this, exactly the same sort of work happens. That actually all your products are going to behave like they did for additions. This 5 here will appear on the top line here. This is it also gets as being part of the split E. It later appears on the bottom line. It will cancel out. This middle 4 here appears on the top line somewhere and will later appear on the bottom line. It will cancel out. The A2s cancel out. The A3s cancel out. A3s cancel out. A2s cancel out. Another A2 cancels out, and that's it. And what you're left with is 9 copies of A1 on the top, and that A9 on the bottom survives. You know, however you want to do this, the product is going to be invariant. It's going to be 9 copies of A1 multiplied together and 1 copy of A9 on the bottom. Whoa. So what was I doing for crazy fractions? In this speedy talk, Well, I was simply choosing for my sequence this time, AN, the nth term of my sequence, to be 1 over n, which means on the side of the page, I was asking you to write a to the A to the B, A plus B, which means I was secretly asking you to write, if you could see it, if my camera were to focus, I was secretly asking you to write 1/8 times 1/b on the top and 1 over A plus B on the bottom. And that looks crazy, that looks hard. So what is that? If I unravel that, that is really, okay, that's going to flip. So I get A plus B on the top, and that's going to be AB on the bottom, which is really 1/8 plus 1/b. That is, when I ask you to write that, I'm really asking you to write the sum of the two fractions. The sum of the two fractions. That's exactly what I was doing, the sum of the two fractions. And of course, when you multiply them all out, I know that that product, wherever it's gone, in my bad board technique, all these cancellations will happen, and you'll just be left with this. You know, you'll just be left with 9 copies of A1 on the top and A on the bottom. But what was A1? It's 1/1. So that's 1 to the 9th power. And what's AN? It's 1/n, 1 over n on the bottom power, which turns out to be n. You are guaranteed, you're guaranteed to have the freaky fractions, wherever they've gone, to give you back to n. Whoa, whoa. Okay, that was 2 minutes overtime. But here's my invitation to you. You are now in possession of power. You can take any number of pebbles you like. I chose 9. 9 seems to be a big enough number to be confusing. Choose 9 pebbles. You can choose any sequence you like, and you can create your own version of a crazy splitting puzzle where you're guaranteed to get the same answer in the end. Choose a nice sequence. Choose like not just the square numbers, maybe do something with the cube numbers, maybe do something with the 4th powers. Maybe do something with logarithms. Maybe because I did exponents, I did basically 10 to the nth before. Maybe do something with the logarithms. Play with this. Maybe this is a trigonometric version. Loads of fun with pile splitting. I love that a classic puzzle can actually emerge. So much depth can emerge from a classic puzzle. It's always worth dwelling on puzzles that have been solved before, because every answered puzzle is really an invitation for deeper thinking and more exploration. So thank you, everyone. That was such a whirlwind of experience, I realized. But if you Google pile splitting, I've done some videos on all of this, so you'll be able to find me talking about this sort of thing. And how did I discover this? Basically what I said at the end, every solved question is actually an invitation for deeper thinking. So I looked at that classic puzzle, just writing down the products as you split piles. I figured there's got to be more going on there. It's just me mulling, probably over days, weeks, knowing my little brain, months. I'm very slow. I'm a very slow thinker. And I realized if we just started playing with sequences, maybe there's a way to get going there. And it was just dabbling and things fell into place, which is the nature of mathematics. But now you've got the power too, Nevin, to really think about this. So I suggest look at my videos on pile splitting so to make sure you get this in your head, because I went very fast tonight. I know I did. And then start playing, start inventing. And then you might realize, well, if I was adding sequences and I was multiplying sequences, maybe you can do other things. In fact, if you know some advanced mathematics, I was using addition and multiplication. Maybe you can start doing other sort of ring and group operations. Maybe you actually like do something with matrices. I mean, that'd be kind of wild. Get some weird invariants just to really freak people's minds based on matrices or something. And yes, Gern, I went at normal speed for me. I realized that. Thank you. Yes, you knew what you were in for.
Yes, that was lightning speed, but it was, I can tell it's also very carefully engineered to be just the right atomic level to be completely comprehensible, even at lightning speed. So,
oh, good. I'm glad.
Well
Excellent. Done. I had fun. Thank you, everyone. Real pleasure to be here this evening. Have a great rest of the night and keep spreading the math joy. I'm so impressed with this organization. So thanks for having me. A real honor.
Thank you again, James.
Okay.
Thanks, everybody.